Fine, guys. So today we are going to start a new module called as Numpy. Okay. So I think in our previous module, linear algebra, so I have given a small introduction to Numpy. Fine. So which is actually called as numerical Python. Okay. Which is called as numerical Python. Fine. So now if you see about Numpy, so before starting, one point about the NumPy is initially NumPy was not part of Python. Okay, so initially this NumPy was part of something called as MATLAB. Okay, so there was a software, if you're aware, in engineering projects somewhere we will be using MATLAB. So this NumPy, okay, was part of that. So later, okay, so they have made the required changes as per Python, and then they have included it into Python, mostly for numerical calculations. Okay, arrays, matrices, all lot of things. Fine. So then we got a package as NumPy. Okay, so now coming to NumPy, the way how you are going to import NumPy is import NumPy, okay, as NP. Here you can give anything. Okay, so you can give your name, my name, anything you can give. Okay, but a standard alias, this is called aliasing, right? So but the standard thing is NP. Okay, fine. So the fundamental thing in NumPy is array, guys. Okay, so the fundamental thing with a NumPy is array. And how to create an array? Simple, np dot array. Okay, so now, okay, and you have, if you see here, so I'm just trying to show you what is the difference between NumPy and list, because this also looks like list, but the only additional thing you are seeing is something called as array. Fine. But if you see a normal list, so what is this, guys? This is a list, right? And if I say 4, 5, 6, so you get 1, 2, 3, 4, 5, 6. Okay, so this is a fundamental difference and the fundamental need why we require NumPy, because this 1, 2, 3 is list, Python list. Agree? 4, 5, 6 is a Python list. Agree? So when you add these two, so it is not adding the elements, it is just extending this list and adding these elements. Fine, it is just concatenating to list. Okay, but you cannot perform numerical operation. Agree? What is numerical operation? I want 1 plus 4, 2 plus 5, 3 plus 6, like that. Fine, you cannot do that in list. If you want to do that, again, you need to go for a for loop and do that. Fine. So, but to treat this, okay, to treat this as numerical, sorry, to perform some numerical calculations on this directly, fine. So you can use the NumPy. Fine. So once you convert the same 1, 2, 3 in the form of array, how you can convert, guys? It's simple. np dot array. Fine. Np, now np, wherever I say np, it's NumPy. Fine. Np dot array, when you pass 1, 2, 3. So now this will become an array. And np dot array 4, 5, 6, it will be one more array. So when you add two arrays, we can do direct numerical calculations. Okay. So now you see 1 plus 4, 2 plus 5, 3 plus 6, 9. Agree? So if you, just to show you, so if you see what is this type of 1, 2, 3, 4, 5, 6 list, fine. So what if I see the type of, it will be numpy.nd array. Okay, n dimensional array. Okay, is this clear, guys?
Yes, Santosh.
Okay, so that is the fundamental difference, because the first question that you should have in your mind is, when you already have list very similar to array, fine, very similar to array, then why you should again go for array? Okay, so the basic thing, the which the name also suggests, is for the numerical calculations. Okay, And performance wise, NumPy arrays are more faster. Okay, more faster, and they utilize less amount of memory. Okay, they utilize less amount of memory. Okay, so for example, if you see over here, so when I'm saying 1 2 3 plus 4 5 6, the output is what is, the output is 1 2 3 4 5 6. How many elements? The output is 6 elements. But here when I say 1 2 3 4 5 6, what is the output, guys? 3 only. Getting? So here it needs, for example, each memory is 1 byte if it is occupying. So 6 bytes of memory it should consume. It consumes only 3 bytes. Fine. So when we do numerical operations, the memory is getting saved. Fine. And these operations are also a bit faster when compared to list. Okay. Fine. So now we will see different types of functions. Okay, in NumPy np.array. So the first thing is the how to create an array. So simple np.array, but inside that you can give any type of data types. Okay, so you can give a combination of string and integer. Okay, np.array type of np. Okay, so okay, so over here you can see, so this is also an array. Fine. And after that there is one thing over here. So when you say np.array of 1 to 3.0, okay, so which is an, what is this? These two are integers and this is a float. Fine. So array automatically tries to do upcasting, guys. Okay, array will automatically try to do upcasting. That means what? It will try to convert. Okay, it will try to convert all the given values to the float value. Okay, because float is considered great in the order of, float will be greater than the integer. So all integer values will be automatically upcasted to float. So 1 becomes 1.0, 2 becomes 2.0 because you have 3.0 over here. Getting, guys? If you don't have any integer, then it's fine. But if you have any one integer, okay, so the values will be automatically upcasted. Getting, guys? But here, if you see, it cannot upcast A. Fine, because it is a string. String cannot be converted into float. Agree? So that's why it will not touch that. Only when it is possible. See, in this case, it is possible, right? Upcasting, because it can convert every other integer value into float value. So then only it will do that. Okay, fine. And that is also only when at least one of them is float. If nothing is float, if all are integers, then it will be integer. But if at least one is float, fine, it will convert, it will do the upcasting and you will convert everything into float. And but if at least one value is different, fine, it will not do. It will just give the value as such. Is it clear, guys?
Yes, Santosh.
Okay. So after that, the indexing is same. Okay. For example, if you have this, okay, np.array of 1 2 3 0. So indexing is same, just like in Python. Okay, 1 2 3 minus 1. Okay. So negative indexing also works. Okay. And slicing also works. Fine. So from 1 to all elements. So from 2 to 3.0, everything works. Fine. Same concept which we studied in the string indexing concept, slicing concept in Python, everything works over here. Okay, cool. So after that, fine. So after that, you have something called as three things, guys, three main things. Okay, so one is for any array, okay, you will have size, you will have shape, then you will have dimension. Okay, so we'll try to understand these three things. So initially, for example, you can create a array from a list of list. Okay, what is this? A list of list. Okay, so when you create this, okay, so it is a outer part is a list. Inside that we are having two lists, 1 2 3 4. Fine. So now this particular thing can have three things. One is size, it can have, one is shape, and one is in dimensions. Okay, what are these? We'll try to understand. See, size is total number of elements, guys. Okay, so what is the size? Let me first run this and create this. Okay, yeah. So if you see, the size is total number of elements. Over here, total number of elements are 4. Agree? 1 2 3 4. So that's why size is 4. Okay, and shape is number of rows and number of columns. Okay, so now you have 2 rows, 2 columns. Agree? 2 rows, 2 columns. Okay, fine. And second thing is the dimensions. Okay, so dimensions in the sense you are having only either row and column. Okay, so you can create multiple dimensions also. Okay, so in that case it will be more than 2, but here you are having only 2 dimensions. That's why n dimensions is 2. Okay, so if you want to create just multiple dimensions, what it does is, for example, see 1 2 3 4, but I want n dimensions is 5, so it will just create 4 open braces and 4 closed braces, so it will automatically make this as a 5-dimensional. Okay, so if you have this, now if you run this, so first thing is size. What is size? Size is just the number of elements. Okay, so my A is this. Okay, what is A dot size? Size is total number of elements. I have 5 elements. Okay, so inside that, what is the shape? That now the shape is this. So overall here, so it is saying that you are having braces. Okay, see 1 2 3, and inside that you are having 5. No, okay, this one, right? Okay, I need to run this. Sorry. So if you uh okay, here nd dimension is equal to 4, right? Oh, yeah, here it is 5, here it is 4. So that's why it is saying outer side, see 1 2 3, and inside that you are having the 5. What is this, guys? 5 columns. Agree? So that's why it is saying dimensions are 1 comma 1 1, and the last one will be the columns. Okay, so if you say 4, right, so you will have, see, first thing will be rows and columns, guys. Okay, and if you, this will be the starting part. Okay, now if you add total, if you want 4, so then will be, this will be one more dimension, this will be one more dimension. Okay, that means what? 2 braces will be for this. Okay, and third one will be the for row, and inside that you will have the actual value. Okay, 1 2 3 4, the whatever the values you are having. Okay, now you need to close this. So over here, the rightmost one, okay, the rightmost one, this is speaking about the rows and columns. Okay, 1 row and 5 columns. Okay, 1 2 3 4 5, and these two are additional dimensions because we are creating it as a 4-dimensional. Okay, because we are creating it as a 4-dimensional, so it will just, by putting two braces and closing, so it will create more number of dimensions. Okay, but the core part is over here, so which is having 1 row and 5 columns. Okay, 1 comma 5, and the dimensions is 4. You can see the dimensions is 4. Is it clear, guys? Or
Yeah,
should I
sir.
repeat? Huh?
I said yes.
Can you repeat again?
Sorry, Meghna.
Repeat again.
Repeat. Okay. See, simple. I'll take this example again. Over here, first is size. What is size? Just count the total number of values, guys. That's it. Overall, 4 values you are having. Okay. So overall, 4 values you are having. For example, if you are having one more 10 20, see, guys, now how many items are there? Total values. See, 1 2. If you see, if you're getting confused with 1 and 2, so I'll take 11 22, 33, 44. Okay. Yeah. So how many values are there? See, 1, 2, 3, 4, 5, 6. Total 6 values are there. That is the size. Fine. A dot size is 6. Simple. Now, rows and columns. Okay. Over here, so if I just print A, okay, so A dot shape is this. Okay, if I just print A, C. Over here, how many rows are there? 3 rows. Columns, 2 columns. Agree? So that's why the shape is 3 by 2. That means rows by columns. Okay, 3 comma 2. Clear? That is shape. Size is just total number of elements 1, 2, 3, 4, 5, 6. And shape is this. In other words, now you can also think when you do whatever the shape you are getting, right? Rows, comma, columns. Okay. If you just multiply that, you will get size. 3 into 2, 6. Fine, because these are the total number of rows, these are total number of columns. So when you multiply this, then obviously you should get the total number of elements. Okay, that is size and that is shape. Now dimensions are just like, you know, see, dimension, the word dimension can be equivalent to shape also, but here technically if you speak, dimensions are like how many dimensions this array is spread. Usually if it is just rows and columns, okay, so it will be only rows and columns. Okay, but you can also create this array in multiple dimensions. How? For example, if you take this array, okay, so if you take this array, fine. So if you create, see, it is saying n dimension means it will take only one. Okay, for example, if you take a 2-dimensional array, fine. Yeah, so over here if I give 2-dimensional array, see, with a 2-dimensional array, we'll try to understand first. Okay, so with 2-dimensional array, what is my array? This is my array. And what is the size of array? Size of array is just number of elements. Okay, total how many elements are there? 5 elements. So that's why 5. This one. Now what is shape? Shape is what? Rows, comma, columns. How many rows? Only 1 row. How many columns? 5 columns. Okay, 1 comma 5. And now if you do 1 into 5, then again you will get the size. Okay. Now dimensions. What are the dimensions? 2 dimensions. Okay. Just 2 dimensions. That means only rows and columns you are having. But the same thing you can also intentionally you can create for 3 dimensions. Okay. Now if I just say 3, okay, if I just say 3, see, it will just create one more braces, add one more closing and opening and closing braces. Okay, which will make it into 3 dimensions. Okay, so in the outer list, okay, so in the outer list, that will have one more list. Inside this list, you are having the actual element. Okay, so it's just creating one more dimension. Okay, so apart from that, everything will be same. The size will be same. The size is what? Still, you are having only 5 elements. And what is shape? Shape is now, see, the last most will be the rows and columns. Okay, the last most will be the rows and columns. Okay, but if you're adding one more dimension, so it will just say 1. Okay, that means what? There is one list inside that. See, this means there is one outermost list. Okay, outermost list. Inside that what? You are having one more list in which you are having 1 row and 5 columns. Okay, inside this you are having one more list where you are having 1 row and 5 columns list, the actual value. Okay, so when you say 3-dimensional, you will have 3 open braces and close braces. Okay, so you can remember the number of open and closed braces will be equal to the number of dimensions. Okay, if you have only, if I say 2 braces, then you will have 2 open and closed braces. Okay, so if you have 4, so you will have 4 open and closed braces. Getting guys?
Yes, sir.
Okay, so over here if you see the same thing I have created into 4 dimensions. That means what? It will just add few more braces and it will create the dimensions. Okay, but the size is what? Size is still the same. Only 6 elements are there. 1, 2, 3, 4, 5, 6. Okay, and the number of rows and columns is what? Now here, as I said, the last most will be the actual rows and columns. Okay, that means it is having 3 rows and 2 columns. Okay, that's why 3 comma 2. Okay, now if it is only 2, that's it. Okay, earlier it was only 2, that's then you'll have only 3,2, but now your dimensions are 4. Okay, so you will have the 4 values over here, so it will just add 1 each for each dimensions. Okay, so total 4 means you should have 4 values. Okay, so apart from the actual rows and columns, everything will be 1 each, and these 1 each will be just the braces that are additionally getting added. Okay, so the other way is, if you're having 4, you can simply understand it by the 4 braces and 4 opening and 4 closing braces. Okay, and the number of dimensions is obviously 4. Okay, fine. So out of this, the most important thing I would say is the shape. Okay, the shape of the any array will be very important. Okay, so fine. After that, yeah. So after that, earlier when we have seen here, so it is directly doing upcasting, right? So when I say, for example, over here, yeah, over here, if you see, I'm giving integer, float, and integer. It is automatically doing it as converting everything into float. Okay, but if you don't want to do that, okay, you can just give type equal to int. Okay, that means you want everything in the integer itself. Okay, so then you will convert everything into the integer. And if you do float, it will convert into float, but by default also it is by float. Even if you don't give also, it will by default convert it to float. But if you want specifically want something into integer, okay, it will convert into integer. And if you want it into string, so it will convert each and every value into string. Okay, so that is a D type. Okay, D type is a data type with which you can control what should be the data type of this every element in the array. Okay, so that means you are specifically saying I want every element in the string format. Okay, that is when every element. But if you want a combination of elements, then you can give them as such. Okay, so you can create them. Okay, so now since it cannot convert these values, okay, all these values into float, fine, because it cannot convert a into float, so it has converted everything into string. Okay, so similarly over here also, see, in the first time when I'm saying np dot array, so I'm having a string, an integer, and integer. Okay, so obviously you cannot convert 2 and 3 into this particular string into integer. Okay, you cannot convert a string into integer, but you can convert anything into string. Fine, so that's why it has created, it has converted 2 and 3 also into string. Getting this? Now if you don't have these, you will have integer. Okay, but if you have a string, so everything will be converted into what? Strings. Getting?
Yes, Santosh.
Okay. Next. And the reason for this is, okay, and the reason for this is numpy arrays are homogeneous, guys. Okay, so if I just miss that point, fundamentally, okay, fundamentally numpy array are homogeneous. Okay, that means what? That means what? Okay, so if I just quickly show you, numpy array are homogeneous or heterogeneous. Yeah, you can see numpy arrays are homogeneous in type. That means it will take all, that means all elements will be of the same data type. Okay, so it would not be possible with the heterogeneous data types. Okay, why? Because numpy arrays are made to be created as homogeneous arrays considering the mathematical operations that need to be performed. Fine, so because you need to perform some mathematical operations, it should be all be of the same data type. That's why if you see, if you understand the logic, So if you have all integers, then it is giving it as all integers. That's fine. But if you have any one of them as float, okay, one of them as float, it is converting everything into float. Okay, that is possible. Okay, but if you have a combination of float, or if you have at least one value of string, okay, then it is converting everything into string. Okay, because it cannot convert a into integer, but it can convert every other value into string. Okay, but at the end of the day, every element should be of same data type. That is called homogeneous. Getting? That is because homogeneous. Why, guys? Because, for example, if I see, I'll tell you. For example, here I'm having 1, 2, 3. Okay. And over here, 4, I'm taking it as a string. Okay. I'm taking it as string. No problem. It will just concatenate. Because there is no need of mathematical operations with only plain Python list, right? Because even in this place, if I take hello also, it will just concatenating the elements 1, 2, 3, and it is just extending list, and it is putting 4, 5, 6. No problem. Okay, it is not doing any mathematical operations. Okay, but over here we are doing mathematical operations. So obviously, if there are different mixed data types, it will be difficult, right? Because if I say 4 over here, okay, so if I say 4 over here, it will get error, right? Because why? It is saying this is converted as a what? This is a integer data type. Okay, now when I say np dot array of 456, okay, because one of the data type over here is string, it will convert these two also into string. Agree? Over here, now if I say this, okay, now if I run this, you are getting 1, 2, 3, 4, 5, 6. Okay, now if I run this, can you see here? It is converting other thing also 4, 5, 6. Why? Because at the end of the day, every element should be of the same data type. Now you are having what two type of data types? One is string and one is integer. Okay, now integer cannot be, sorry, string cannot be converted into integer. Okay, in some cases, see, if it is 4, it can be converted. Okay, but usually all strings cannot be converted into integer. For example, if I have apple, can you convert that into integer? No. Okay, I have some English, any character, English character, you cannot convert that into integer. Okay, but every integer can be converted into string. Just put it in the quotes. Okay, so that's why if there is at least one string, if it is at least one string, it will convert every other elements also into string. Getting? So that's why even if I declare it as 4, 5, 6, where 4 is string and 5 and 6 are integer, but what did I get? I got everything as string. Now you are trying to add integers 1, 2, 3 plus strings 4, 5, 6. We cannot add that. Is that clear? Are you following, guys? Any confusions?
I'm following Santosh.
Okay. So can you just attempt and try to say this? If I'm having 2.0, okay, I am having over here 4. Okay, so can you just guess what will be the output? We'll break it down. So when I say 1, 2, 3, so what is the array it will be creating?
Complete float.
Okay. Now this one 4, 5, 6.
Integer.
Okay. So when I add both this, okay, you got the float.
Yes.
Okay. So now when I have 5.0 now,
No, this 4 and 5.06 are completely converted into float. So entire this is also float.
correct. Okay. You can add integer and float, right? 5.0 plus 1, what? 6.0. Okay. Now, guys,
Not possible. Error.
why?
That 6 will be completely converted into
Correct.
okay. Yeah.
Correct. Okay. But any guess now?
It will concatenate both. No?
No, see, NumPy will do only numerical calculations.
Okay, yeah. Sorry. It will only do numerical calculations. That's why. Yeah.
Okay, so these are not like plain list.
Yes.
Okay, fine. So now, actually, that's a good point we have studied over here. So okay, so is it clear, Meghna? Any doubts, or should I repeat something?
No, sir, clear.
Okay, fine. So always remember the elements will be homogeneous in nature. Okay, so and after that, yeah, I was just saying, so you are having 1, 2, 3, and if you want to control the data type, okay, now if you want to control the data type, so these are some codes, guys. If you're thinking what is u less than 32, okay, so it is just codes for the different data types over here. Okay, for example, if I am having, okay, so this 32 is a 32-bit kind of thing. Okay, and here over here, if I say data type, I want it as int. Okay, so it will create everything into int. Okay, I want string, it will convert everything into string. Okay, so that's fine. And then we have seen the dimensions, shape, and in dimensions also. Okay, so after that, what do we have? Yeah, you can also do complex also. 1, 2, 3 data type complex, it will convert everything into complex. Okay, fine. Next thing is data type consisting of more than one element. Okay, so over here, when I'm saying np dot array, so over here what I'm doing, inside that I'm having tuples. Okay, two tuples. And what is the meaning of this is, yeah, so the meaning of this is, see, this is one tuple, this is one tuple. Okay, so any tuple, if you take 1 and 2, okay, one is considered as A and 2 is considered as B. Okay, so now what is a 1? 1 is A. So A data type will be this and B data type will be this. Okay, so let's try to understand. Okay, so over here, if you see, yeah, so if you see I of 2, okay, I2 is the code for what? 16-bit integer. Okay, so in integer also you have different bits of integer. Do you agree? So same value you can store it. We have like 8-bit, 16-bit, 32-bit. I think we are as of now in 64-bit. Okay, so the same value, okay, the system saves it in different types of bits. Fine. So what is 1 byte? Okay, you will have 8 bits. Agree? So you can save it in 8 bits, 16-bit, 32-bit, 64-bit. Okay, so now here I'm saying A will be what? I2 is 16. Okay, so why? Because if you see what is my x is this one. Okay, what is x of 0, guys? X of 0 is 1 comma 2. Okay, x of 0 is 1 comma 2, and x of c, what is x of 0? 1 comma 2. What is x of 1? 3 comma 4. Okay, now what is x of 0? 1 comma 2, and what is x of 0 of 0? 1. Okay, now what is x of 0 of 0 type? X0 of 0 type is I2. I2 is 16-bit. Okay, now it's saying numpy dot int 16. Okay, now what is x of 0 of 1? X of 0 of 1 is 2. Okay, x of 0 of 1, that means this value. And what is the data type I'm saying? 4. Okay, now what is a 4? It is 32-bit. Okay, so this will be 16-bit. This will be 32-bit. Okay, similarly the same thing goes for 3 comma 4 also. So how will you get 3 comma 4? X of 1 comma 1 will be 4 and x of 1 comma 0 is 3. Okay, so over here if you say x of 1 comma 0, 16-bit. Okay, and x of 1 comma 1 will be 32-bit. Okay, is it clear?
Yes, Santosh.
Okay, so after that we are going to see creating an array from subclasses. Okay, so that means what? Creating a matrices. Okay, see, matrix is a subclass of array. Okay, so that means what? Every matrix will also be an array. Okay, but every array may not be a matrix. Okay, we'll see. So if you want to create a matrix out of this, okay, np.mat of np.array. So if you're having an array and if you want to create it into matrix, just say np.mat. This is a matrix. And once you have matrix, what you can do, guys, you can do all those matrix multiplications which we studied in the linear algebra. Okay, matrix, what all we studied, yeah, so we studied different types of operations, right? Dot product, cross product, everything. So for that you need the matrix. Okay, so you can create, and the other way of creating matrix is also simple: 1 comma 2 semicolon 3 comma 4. Okay, so it will create the matrix. Okay, fine. So after that you are having something called as array. Okay, so as array is sorry. Okay, so see, simple, a equal to 1 to 1 2, it is a type of a is what? List. Okay, so as array is also similar to array only, guys. Okay, I would say there are like not much differences between as array and array. Okay, but there are only few things you need to understand here. Okay, so for example, if you see np dot as array, okay, so when you pass a, it is also creating it into numpy dot nd array. Same thing. So np dot array also will also create it into np dot array also will create it into nd array. Okay, so this is array, this is as array. Okay, so np dot array also same thing. Okay, but if you see np dot as array 1 by 2 array, okay, if data type is set, array is copied only if the data does not match. Okay, see, np dot array 1 comma 2 data type equal to float. Fine. So now np dot as array 1 comma 2 is a. Okay, yeah, so these things we'll need to understand. See, guys, when I'm saying np dot array 1 comma 2, it is creating what? It is creating me 1 comma 2. Okay, now when I say np dot as array 1 comma 2, okay, np dot as array 1 comma 2 is a. Okay, now what is this np dot as array?
Integer.
Integer. Okay, so but here I am creating this array in the form of float. Now this is float. Okay, so when you say np dot as array 1 comma 2 is a, no, it is not a, it is false. Okay, so that is one thing. Second thing is np dot as array. Okay, np dot as array of a. Okay, now what is a? A is this. Okay, and over there, when you want to, when you convert them into float again, okay, is a. Okay, see, what is a, guys? A is 1 comma 2. Okay, so a is 1 comma 2 and data type is float. I'm converting it into float. Okay, so now this will become, no, what is this? This is 1 comma 2. Okay, as array. And a is also created as what? A is also created as np dot array. Array is also created with the float. Okay, so obviously it will be true. Okay, so it might seem similar, but I will show you what is the difference between np array and as array. Okay, np array and as in the array method creates a copy of an existing object. Okay, whereas as array creates a new object only when it is needed. Okay, so that you will understand when we are discussing in some time. Okay, when we are seeing just we have copy, yeah, when you're having copy, right? So then you will understand that. Okay, so just bear me a minute. Okay, so after that you have something called as Where are we? Where are we? NP dot as array is a. Yeah. So over here, as I said, matrix is a subclass of ND array, guys. Okay. So matrix are a subclass of arrays. Okay. So that's why it is saying it is true. Fine. So once you have that, okay, I am saying NP dot matrix of 1 comma 2. Okay, and NP dot as any array. Okay, you convert it into as any array of A. Fine. So it will give you this. Why? Because if you see here, matrix is also an array. Okay, so matrix is also an array. So when you want to convert it into any array, it will not touch anything. It will directly give the matrix. Okay, see, don't get confused. I'll just show you with another example, then we'll understand. Where was the example? 1 comma 2. Yes, yeah. Over here, if you see, you will understand. See, guys, when I'm saying A equal to 1 comma 2, what is 1 comma 2? It is just a list. Agree? With that list, if I'm saying NP dot as any array, okay, convert it into any array, then it is converting it into array. Okay, this is array, this is not list. You can see the word array. Okay, fine. But now, if I create a if I have a matrix, okay, if I have a matrix, and when I say convert it into array, it will not convert it into array because matrix itself is also an array. Okay, getting is when you're having list is not an array. That's why it will convert it into array. Okay, see A1 comma 2, this is a list, not an array. So because if it is not an array, it is converting it into an array. But now if you are giving matrix input matrix equal to A, and if you're asking it to convert it to some array, first it will check whether the given thing is an array or not. The given thing is what? It is a matrix. Matrix is also a subset of array. So that means it is also an array. Fine. So that's why it will just give you the matrix itself. Getting? Because if you see here, is matrix subclass of array? Yes, true. So that's why it will not again convert it into some other array. It is already an array. So that's why it is not converting it into array. It is just giving out the matrix. Okay. But if the given thing is not a matrix or it is not an array, it is simple Python list, then it will convert it into array. That is the use of as any array. Is that clear? Or shall I repeat? If not following, don't hesitate, guys. Tell me, I'll repeat. Okay, I'll repeat. See, guys, simple. As any array will convert it into some array. But when, first of all, it will check whether the given value is an array or not. Is array or not, first it will check. Okay. That means what? Even if it is a matrix, also that is considered as an array. Why? Because as I said, matrix is a subclass of array. Okay. Everything is an array. In that, a special class is matrix. That means what? Matrix is also a subclass of array. So if it is matrix, it is already an array. Okay. So now when you are giving simple 1, 2, what is 1, 2? 1, 2 is simple list. It is not array. It is not matrix. Nothing. Fine. In that case, this np dot as any array, when you pass this A, it will convert it into an array. You got array. Okay. Now, in second case, when I am passing matrix, input dot matrix 1, 2, now matrix is also an array. As I said, matrix is also subclass of array. So this is already an array. So when it is already an array, you don't need to do anything. So even if you pass input dot as any array, if you're asking them to convert, it will say, hey, the given matrix is already an array. I don't need to again convert it to an array. So it will just give you the matrix.
Yeah, Santosh, got it.
Clear?
So matrix basically two-dimensionally, right? By default.
Yeah, by default, No, it depends on how many dimensions you are giving.
Okay. So, but
Yeah.
just now we can see 2 dimensions. Is
Yeah,
it
here because I have
2 dimensions?
created it into 1, 2, right? You can also
Okay.
create as now it become 2 dimension. Or it will become 3 matrix must be 2 dimensions. Oh, sorry. Is it? Yeah, I think you are right, Karthik. I thought it should be more than 2 dimensions also. Okay. Where did you see matrix is this 2 dimension?
Just I mean, based on output I have earlier, you gave matrix of only have given single back bracket, but still in output I can see 2 brackets.
Oh,
That's where,
is it?
yeah.
Let
So,
me put up a solution. Over here. Oh, okay.
yeah, that's
Thanks. Let me note that point out. Okay, fine. So if it is array, it will give you an array. Okay, because array is also one of the because if it is an array, you don't need to convert it into again an array. Similarly, if you have a matrix also, you don't need to convert it into array because that is also a array. Okay, fine. So after that, you have something called as copy. Okay, so numpy.copy. So in Python, we have 2 types of copy. Okay, what is shallow and deep? Did we discuss this in our Python classes?
no, Santosh. It seems no.
No. Okay, fine. See, guys, shallow and deep copy. So I'll show you a simple example. See, I'm having a equal to 100. Okay. Now, what is a? 100. Fine. Now I'm saying b equal to a. Okay. Now what is b? This. Okay. So now, what is type of a? Integer. Okay. But what is idea of a? Sorry, this one. Okay. So if you see, there is some memory ending with 88. Okay. Initially, when I say a equal to 100, what happens, guys, in the memory space? It will pick up some memory. Randomly, it is picked number 88. Okay. Over there, it will name this memory location. This is memory location. The address of this memory location is, see, observe my terminology. The address of this memory location is the ending with 88. Okay. I'm just calling it as 88. Okay. This is the address. Okay. Inside, you can say RAM. Okay. What is the name of this memory location? A. It has given A. What is the value inside that it is putting? 100. Okay. 3 things. This is a name. This is a value. Clear? This address will be is permanent. Okay. That means it inside the RAM. So fine. So you will have a lot of memory, right? So each bit, okay, each box over here will have some address. Okay. That will be common. I mean, that is permanent. Fine. But what value it is storing will constantly change. Okay. Today, if I'm running this notebook, some value A might be stored. Tomorrow, if I'm watching a movie, something will be stored in this. Okay. Song might be stored over here. Some calculation might be stored here. In the same box, it might change continuously. Okay. Now, as of now, when I say this address is 88, with this address, as long as I'm running this notebook, this address, I cannot call by this long digit, right? So it is giving some name that is a variable. Okay. A. I'm giving a name A. So this memory location I can refer by this A. Whenever I say A, the Python interpreter will automatically go and use this particular location. That is A. And what value it will give me? It will give whatever the value I'm storing over here. It is giving me 100. Okay. It is storing me 100. Okay, so this 100 will be stored in what? The bit format, whatever the bit or byte format, which I have just showed. If it is 32 bit, okay, simple 8 bit, okay, this 100 will be stored. Same thing for every other value. Okay, is it clear, guys? How the memory will be stored inside? Okay, fine. So now if you see, interestingly, observe this. A is 100, fine. I'm saying B equal to A. A is already created. I have created one more variable. Now I'm creating one more variable B. What I'm saying, that is equal to A. I'm just saying A. Now if you see, when I'm printing ID of A, ID of B, what is happening is same value I'm getting, exactly same. That means what? For the same memory location, I'm also creating one more name called as B. Okay. Okay, I'm creating one more memory location, sorry, one more name called as B. But both of them are pointing to same memory location. Okay, both of them are pointing to same memory location. Even if you say A also 100, even if you say B also, it's 100. Okay, both are 100. Okay, so what is happening? It is using only one memory location. Okay, that means what? If the value is changed over here, both will be affected. Okay, or any number, even if you say, even if you create C comma D, like for example, if you say C equal to, just like B equal to A, if you say C equal to A and D equal to also A, okay, but even if you are having 4 names, it is just 4 names, but the same memory location, the ending with 88, single memory location is referenced by 4 different variables. Okay, but if you change this value, all of these 4 will be affected. Why? All of them are pointing to the same memory location. Is it clear? I'll show you so that you can understand. See, I'm having this. Okay, so see, I'm having A equal to 100. Now I will say first I will write here B equal to A. Okay, so I'll write print of A. Okay, print of B. Okay, both are 100. Okay, now now I'm saying A equal to 500. Okay, A equal to 500. After that, I am printing A and I am printing B. See, oh, okay. When I say A equal to 500, it is creating a new memory location for A. Okay, wait guys. When I say A equal to 100, so now if you see the value of, now when you see the value of A, okay, when you see the value of ID of A, that will be different from this 88. Okay, why? Because if you see A equal to 500, when I say A equal to 500, what is happening? So it is creating, it is picking up one more new memory location. It is picking one more new memory location. Okay, and it will name that as A now. Okay, and it is putting the value of 500. Why? Because of the immutable concept. Once if in a Python, once if you create a value, okay, I mean the immutable data types, once if you create a value, it cannot be deleted as long as the notebook is running. Okay, so that's why if you see, here, when I print, earlier it was this 88 and 88. Okay, but now if I print, the value of A is different. Getting? The value of A is different. Why? Because now A equal to 100, sorry, A equal to 500, that means what? The 100 will stay here forever. Are you getting this? I have created memory location 100. Initially A and B are pointing to A and B. Now when I say A equal to 500, fine. That means what? Now A, instead of pointing to 100, it will create one more memory location with ending with what? 32. Okay, it is ending with 32. Okay, memory location. Now A will point to this and the value will be 500. But 100 will stay here only, because once you created a value, it will not be deleted. Okay, now B will still point to same thing. B will still point to the same thing. If you see the B value, it is still 88. if you see the B value, it is still 100. Are you getting?
Yes, sir.
Okay.
Yes.
Now if you see, for example, if I say C equal to 100, if I say C equal to 100, okay. So first what it will do, first it will go and check in the memory location if at all there is any memory location holding this value called as 100. Okay. If it is holding, then it will take that C and start mapping it to the same value. Because why? Because I want C equal to 100 means what? I want a memory location. Sorry, I want a variable that should have value of 100. Agree? What is the meaning of C equal to 100? I'm saying indirectly, I want a memory location where the value should be C and the name should be C and the value should be 100. This is what my requirement. The value should be 100 is my requirement. So first it will see in all the memory locations whether already any memory location is holding the value of called 100. Is it there? Yes. The memory location ending with 88. Okay. So is having 100. Okay. So, but as of now, which one is pointing to it? Only B is pointing to it. Agree? Only B is pointing to it because A is now shifted to 500. Clear? So now B is pointing to this 88. So now I'm saying C equal to 100. C equal to 100. So C should also point to 88. Okay. But let's see whether that is happening or not. Okay. So now when I say print of C, so let me print C. Okay. And print ID of C. Okay. Yes. So if you see C is 100 and print of ID of C is what? This value is exactly the same value as this 0, 20, 4688, 4688. So that means what? It is pointing to the same value. It is using the same memory. Did you follow? No? Shall I repeat
Yes,
or
sir.
what?
Clear.
Okay, fine. So now over here you have something called as in the list part. Okay, in the list part, if I show you, okay, this part is clear, right? Okay, so if I just remove this, okay, so in the list part, Meghna, do you have college today?
Yes, sir, I have.
Oh, okay then. Fine. So this will take some time because I need to show example of list and then I'll show you the shallow copy and deep copy. Okay. So fine, we can continue this tomorrow because it will take like 10 more minutes. Okay. Fine. Yes. So that's I would say introduction class of NumPy. Okay. So there are two things I will do. So today I will share the stats notes. Okay. I couldn't share it on the weekend. So and second thing is I'll also share the NumPy index also. What are the topics we need to cover? Okay. So yeah, so these are just the basics which you have covered. Okay, so there are like a lot more functions in the NumPy matrix which we are going to cover. Okay, so fine, guys, that's all for today. So we'll meet tomorrow.
Sure, Santosh. Thanks.